Okay, let's look at page 30. Okay, number 4. From 2016 FRQs. Okay, so on the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. So we want to identify all the locations of these order pairs, and one by one we insert into the differential equation. And whatever number we get back in return, we translate that into a short slope segment. Okay. So for instance, if I plug 0 in for x and y, my order pair is 0, 0. I get 0 over 1, which is 0. So I need to draw a horizontal line. So slope 0 is a horizontal line. If you get slope undefined, then it's not a vertical line. It's just going to be blank. Okay, so nothing for slope undefined. But here it's just slope 0. Next up, 0, 1. My order pair is 0, 1 here. So if I plug 0 in for x, 1 in for y, I get 1 over -1, which is -1. Next up, let's substitute order pair 0, 2. 0 in for x, 2 in for y, 4 over -1, which is -4. So negative slope, we can make it a little steeper. Next up, order pair, this is at 2, 0. 2 goes in for x, 0 in for y, so 0 over -2, 0 over 1 is 0. We want to do a horizontal line for 0. Next up, 2, 1. So 1 squared over 2 minus 1, so 1 over 1 is 1, positive slope. Two in for x, 2 in for y, so 4 over 1, which is 4, positive slope. All right, part B. Let y equals f of x be the particular solution to the given differential equation with the initial condition f of 2 equals 3. That's my starting point. Write an equation for the line tangent to the curve of the graph of y equals f of x at x equals 2. So we want to find order pair, find slope, point slope form, and then finally linear approximation. We'll insert that 2.1 in for the x. Okay, so our slope comes from dy dx. It's our slope formula. Right, so 2 in for x, 3 in for y. 3 squared over 2 minus 1. So 9 over 1 is 9. That's my slope. All right, point slope form. All right, we'll solve for y. So now that we have our tangent line equation, we're going to use this equation to approximate f of 2.1. So we just insert that 2.1 in for x. You can leave your answer like this. This is perfectly acceptable. Or 3.9, but I don't want to. Without a calculator, we should leave our answer unsimplified and we're good. All right, part C, find a particular solution. So we just have to solve this differential equation. So cross multiply, separate the variables. take antiderivative of both sides. Let's multiply. I want my dy's on the left initially and dx on the right, and we'll see how things play out. Okay, so now we have to decide how do we get full separation, because we have our dy in the right spot. We have dx in the right spot as well. The only thing left are the x's and y's in the right places. So we want the y squared over here on the left side. We want the x minus 1 over here on the right side. We're going to make each other divide to the other side. And as they divide, they're both going to land in the denominator of the other side. So x minus 1 moves over to the right, y squared moves over to the left. Right, full separation of variables, dy up top, y on the left side, dx up top, and x is on the right side. And as we take our antiderivative, we know that this y squared is a little bit out of place. We do want to apply power rule here. So we'll bring this up to the top. The right side, we can set it up for use substitution. All right, so power rule, y to the negative 2 becomes y to the negative 1 over negative 1. Here, my 1 over x minus 1, my u value would be x minus 1. My du dx would be 1. Solve for dx, dx equals du over, du over 1, or 1 du. Make my substitution, I have 1 over u du, and we know this lands nicely to turns into a natural log problem. Okay, so right side, 1 over u du, which ends up being natural log as value of u. Okay, let me bring the original variable back. And I'll clean up my left side as I do that as well. Right, so as soon as the plus c shows up, I can decide to solve for c at any point in time after that. Let's just go ahead and get that out of the way before any messier fraction comes up. So let's go ahead and solve for c. We have our order pair, 2, 3. 2 in for x, 3 in for y. Right, natural log of 2 minus 1, so that's natural log of 1. Natural log of 1 is 0, that goes away. So negative 1/3 equals c. Once we have our c value, we can go ahead and reinsert back into the equation where we started making that substitution. So we'll put in that negative 1/3 here. All right, so we're almost there. To earn that final point, we just want to find a way to get that y by itself. Eventually, I want to flip it, but let's go ahead and just distribute everything through with -1 just to move that negative to the other side. Okay, so one more step to go, and that's to flip that y to the top. If I flip that y to the top, I can, whatever I do to one side, I can do to the other side. So I'm going to flip this whole thing to the denominator. So I'm flipping this whole thing to the numerator. Now, I can't pick and choose here. I can't say, okay, I'm going to flip this one to be 1 over natural log and flip this one to be 3. That plus sign prevents us from separating that process. We got to put this whole thing in the denominator. And it looks a little messy, but you can leave your answer in this form, because as long as we get y by itself and our c is resolved, we should be good. Any questions? All right, let's go to page 31. Okay, the inside of a funnel of height 10 inches has a circular cross section. Okay, so that's a bit of a hint here. Circular cross section. As shown in the figure above, at height h, the radius of the funnel is given by r equals 1 over 20th 3 plus h squared, whereas h is between 0 and 10. The units of r and h are inches. Find the average value of the radius of the funnel. Okay, average value of the radius. Okay, well, here's the radius, average value. I can just go through average value theorem. Okay, which is 1 over b minus a, integral from a to b of, in this case, r of h. Okay, so our a and b values are 0 and 10. I'm going to put this up here, save the bottom for b and c. All right, now this is a little bit tedious because all that's required here is power rule and evaluating, but without a calculator, it's going to take a little bit more time. So, but we can leave our answer in unsimplified form. It's just, a little bit of a messy process. All right, so first thing I'm going to do is I'm going to distribute the 1/20th through. Maybe I can just merge even the 1/10th and 20th together. So there's a lot less fractions to worry about here. But what if I just multiply everything through, including the 1/10th and the 20th. So I have, this is 1 over 200. So I can distribute everything through and make it 3 over 200 plus 3 over, 1 over 200 h squared. So if we look, both of these are separated. Nothing is influencing these terms. These are standalone terms. We can make each of them go through power rule. H is our variable. So we'll make this 3 over 200h plus 1 over 200 times h cubed over 3. And now I took care of that 1/10th already, that leading coefficient, and now I can work in my bounds. So upper bound first is 10 followed by 0. So I'll plug in the 10 first. 10, I get 3 times 10, which is 30 over 200 plus 10 cubed over 600 minus, now the 0 is just going to wipe itself out. So I'm left with 30 over 200 plus 1,000 over 600. Okay, now we can simplify this down to an easier number, but why bother if we're already staring at the right answer? So this is fine, or any variation of this is fine. Okay. If you decided that you want that 1/10 sitting out there and you waited for that 1/10 to distribute through, you're good. All right. So any variation of these fractions or is fine. Okay, so far not too bad. We just had to do a little bit of extra steps to show all of our work. Part B is what threw students a lot off a couple years ago when this was given. It says find the volume of the funnel. And I think some students were looking at this thinking, wait, is this like a similar triangles problem? Maybe I have to do that, but this is not a triangle, right? We got a curve region here. But the hint is here. It's a circular cross section. Circular cross section. And the reason why it's so difficult is because in order to see things a little better, we really need to kind of turn this shape sideways. Okay. If we turn the shape sideways, okay. Imagine this is the axis. Imagine that this is the curve. Imagine that this is now the H. The H is your x-axis, and then your R is your y. And this is what's happening. We're taking this graph, and if we rotated that graph along this quote-unquote H-axis, then we can kind of visualize, oh, wait, this is a disk method problem, right? But, I mean, getting to this point is kind of hard, right? So a lot of students struggled and did not like how this problem was set up, but this is how it is. H is the X, R is the Y, and we think that, okay, if I were to take this and rotate it around, then yes, then this is the shape that will come up, right, after that rotation. That's the object that's created. So we know it's going to be this method. We know that our there's no gap between the axis and the shaded region, so we can extend from the axis to the boundary of our shaded region. And we'll let that be our big R. So our big radius is top minus bottom. The top is the 1/20th, 3 plus h squared. The bottom is the h-axis, the 0. A bounds is from 0 to whatever this height is, and that height is 10. So here's our formula here. We know this method. Minus 0. Balances from height of 0 to a height of 10. Make sure we square our radius. Now, you would think that this is a calculator problem, but this is one that is asked to do by hand. So let's go through this process. I got to square everything here. 1 over 20 squared times 3 plus h squared squared. So I'm going to FOIL all this out here and then just do power rule for all of these. Gonna put it in descending order here. Now, we have to take advantage of the fact that they don't ask us to simplify anything. So let's just, leave it as messy as possible, and we should still be okay. So it's power rule, h to the 5th over 5. Keep the coefficient. And then the constant will go to linear. Okay, so this one big mess, we just have to evaluate between 0 and 10 and leave our answer in that one big mess. Okay, don't forget there's still a pi out here in front here. And then just say this times pi. It does clean up to be a nice or a cleaner fraction, but why go through that trouble when we have everything in front of us? So it's almost like infinite variations of this answer and still be able to earn full credit. Okay. Okay, so now part C says the funnel contains liquid that is draining from the bottom at the instant when the height of the liquid is 3 inches. The radius of the surface of the liquid is decreasing at a rate of 1/5 inches per second. At this instant, what is the rate of change of the height of the liquid with respect to time? So there it is with respect to time. We know there's a related rates problem. Okay. Okay, so related rates, we know our equation is this R equation. Let's distribute everything through here. So we know that as we find our derivative, every variable is going to get impacted by time. So we're going to expect a dr dt and a dh dt. So let's go through that process, find the derivative so they can get that out of the way. R becomes dr dt, change in radius over time. 3 over 20 is a constant that goes away to 0. So leave that term out. Next, we go through power rule. 1 over 20th times 2h. And then dh dt. Okay, let's gather some information here. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing. So that's dr dt is negative, right? That word decreasing tells us we're dealing with a negative rate. At this instance, inches per second. What is the rate of change of the height with respect to time? So we're looking for dh dt. Okay, we should have everything in front of us. We have h to insert. We have dr dt to insert, and then that leaves us, dr dt to insert on this side, and that leaves us to solve for dh dt. That's our missing variable. So I'm just going to insert this into my derivative. Six over 20 reduces to be 3 over 10. Right, solve for dh dt. So divide both sides by 3/10, or in other words, multiply both sides by 10/3. Negative 10 over 15 reduces to be negative 2/3. Inches per second. Good. All right, last one here, number 6. All right, these are, I think it's pretty straightforward. The part A, let's see, function f and g are continuous, second, and have continuous second derivatives. Okay, so smooth curve all the way through, first, second derivative, and the function. Table above gives values of functions and each derivative selected for values of x. Let k equals f of g of x. Write an equation for the line tangent to the graph of k at x equals 3. Okay, so we have to find order pair in using the table. And we also have to find the slope. And to find the slope, we got to find the derivative. And to find the derivative, we have to realize that f of g of x is a function within a function. We don't want to get this confused with the product rule here. This is chain rule, right? Chain rule here. So we know we have to work our way to chain rule here. Let's go ahead and find the easy stuff first. Let's find the point. We know our x value is 3, so let's go ahead and insert 3 into the x variable and solve for, see if we can find our y value. Okay, so f of g of 3, let's figure out what g of 3 is first. So g of 3 is 6. So g of 3 gets replaced with 6, and now I can evaluate f of 6, and f of 6 is equal to 4. Right, there's my order pair. Next up, I need to find my slope. To find the slope, I first have to get to the derivative. To get to the derivative, there's chain rule here. Okay, so we got to do outside derivative times inside derivative. We'll take care of the f first. and then we'll take care of the g. So f prime of g of x will take care of the outside derivative multiplied by inside derivative, so g becomes g prime. Okay, replace every x with 3. All right, so piece by piece, we got to insert information in and see if we can make our way down to an exact numeric value. So I'd like to start with the most inside portion first. G of 3. G of 3 is 6. And now that I've replaced that G of 3 portion, it feels a little bit cleaner in terms of what I can do to get to my answer here. F prime of 6, that's the slope of the F graph at 6. F prime of 6 is 5. And then G prime of 3, that's the second part of my derivative here, G prime of 3. G prime of 3 is 2. So K prime of 3 is equal to 10. That's my slope. So I have my ordered pair. I have my slope. Now I'm ready for point slope form. All right, I want to substitute my x1, my y1, and my slope m. There's my ordered pair. Okay, this is perfectly fine. Leave it in this form where we can solve for y. This is acceptable. Part B, let h equals g over f, find h prime of 1. So what do we have to go through to find the derivative here? Quotient rule, right? I think a lot of students do this. They want to take a shortcut. They just do f prime over g prime over f prime, and they just find f g prime of 1 over f prime 1. That's not quite it. We got to go. It's a little bit more complex than that. We got to go through the full chain rule, quotient rule. So quotient rule. In this case, it's going to be g prime f minus g f prime all over f squared. It feels weird writing it this way, but it's going to be the top's derivative times the bottom minus the top times bottom's derivative all over denominator squared. So we build out our derivative, and the rest should be a lot easier because we can just substitute from the table above. So this is quote unquote my f prime g minus f g prime all over g squared. But because my f and g are flip-flopped, everything seems backwards. Okay. Once I find my derivative, I'm going to evaluate my derivative at 1. So replace every x value with 1, and then just pull this information from the table. Right, g prime of 1 is 8, f of 1 is -6, g of 1 is 2, f prime of 1 is 3, f of 1 is -6. -6 squared will give us 36. We can leave your answer like this, or you can go a little further. It's not too hard. Reduce it all the way down, but any of these are acceptable. Okay, good. All right, so last one, part C. Evaluate the definite integral f double prime of 2x dx, right? We know f double prime is going to rise up to f prime, but we got to be careful that 2x requires us to go through use substitution so that we can keep track of our coefficients as well as adjust to our bounds. So I'm going to focus my attention on just this 2x here. Okay. Use substitution. Once I make my substitution, or once I find my u and my dx, I can make those substitutions. Pull the 1/2 out in front. So now it's nice and clean. I took care of that 2x, and now I'm going to evaluate or take my indefinite integral. So I know f double prime is going to rise up to f prime. Okay, I find it easier to just bring the original variable back. So we're done with the calculus. When we're done with the calculus, or the 1/2, I'm sorry, the integral notation drops out, the du drops out. So we're sitting at the antiderivative. We made f double prime rise up to f prime. Now let's bring in our original variable, and now we can work in our 3 and 1. So what you don't want to do is you don't want to leave this in terms of u and then insert the 1 and 3, because the 1 and 3 are in terms of x. But here, this is in terms of u. So either you convert your bounds to be in terms of u, or you convert your integrand to be in terms of x. I think most students prefer in terms of x. So we'll do that. And now we are matched up and ready for our bounds. All right, upper bound. 3 goes in for x. Two times 3 is 6. Almost there. F prime is 6, F prime of 2. We can just look at our table above and find those values. F prime of 6 is 5. F prime of 2 is -2. Keep track of your negatives here. Okay, good. All right. I'll have a help session tomorrow evening and Sunday. I will send out Remind and the Teams link. But just as always, I will record both those sessions, and I'll focus on the 2012, 2014 multiple choice, as well as any of the recent packets that you picked up. If you're not here, if you weren't here in class, all those packets and handouts are all under Sunday, May the 8th. All right, feel free to send me any questions that you have through Remind. But good luck with your studies this weekend, and maybe I'll see you tomorrow or Sunday. Okay, have a great day. Have a great weekend.